we're going to cover all 9 of these graphs. We're gonna kind of introduce them all today, and then go into more detail on each of them. And we do this right before the end of course exam because it helps you on the end of course exam. You have a whole portion. I'm trying to find it back there about statistics and data. Okay, you have to know how to read these different types of graphs, and many of them you have familiarity with. Some you probably have no familiarity with. So the goal is for you to become familiar with them and understand how to use them and how to read them. Okay? So that's the front page. And I know this is a packet, but you're done with page 1. It's just a reference page for you. We're going to move on to page 2. And this is where we take all 9 of those graphs and we're going to break them up into each one here. So the first one we're dealing with is line plots. Now, if you wanted to reference back to page 1, you would see there's some information about line plots. It's actually number 6 down there, but shows all the data in order by frequency. Okay, so what we're going to do is going to go through and just get a real broad overview of what a line plot is. All right? So what I want you to do right now, the best you can with your neighbors, just go ahead and go A through F there. Just based on what you know, use a pencil because we may have to change things up. All right? Okay, here we go. So line plots. The line plot at the right shows the ages of the dogs that were at the local Lake Stevens dog park yesterday. How many dogs were at the park? Well, first of all, the line plot, each X represents how many dogs?
3.
What does an X represent here? 1 dog? Okay, each. And so what does this mean right here? There's 1 dog that's 2 years old. Good. So we have the ages of dogs, but each X represents a dog. And it also tells us the age, right? This dog's 2 years old. How many dogs are 3? 3 dogs are 3. How many dogs are 8? 2 dogs. Okay. So how many dogs were at the park? We get 10. All right, 10. What's the range? What does range mean? Peter?
The 8 does come up 8 here, like 2 to 10.
Yeah. So yeah, you're going the age here. You're going from smallest to greatest. So in this case, we're going from 2 to 10 years old. The youngest is 2. The oldest is 10. Good. All right. What's the median? What does median mean? So on some of these, it may be nice to have either off to the side you're defining what some of these are. Okay. Kelly, what's median?
It's the middle number.
It's the middle number. What else do we? How do we set up the middle number? Go ahead.
Don't you line up like all the numbers, and then you cross them out until you get to the middle?
Yeah, the median is the middle number when the data is in order from least to greatest or greatest to least, when it's in numerical order. So if you didn't know the definition of that term, middle number when the data is in numerical order. All right? And it's nice if you use a pencil like I told you guys. Okay, so it has to be, the data has to be in numerical order. So I wrote it on there just so at the end of the unit, when we're done, we have about 10 days worth of stat stuff. When we're done with all the stat stuff, it's nice if you have it on a separate sheet of paper. That way when you're studying for your quiz, you can go, oh, these are the things I didn't know, versus having to shuffle through all your packets. So you don't have a clean sheet of paper out or a note page out that you want or that you're taking notes on, now might be a good time to grab one. So if you want a note page, I'll put some out there, you can grab one. Otherwise, get a piece of paper out. Okay, well, you guys are grabbing your note page. I actually was able to find my pencil, which makes things a little easier. All right. So, in terms of the median, we've got to put things in order. What numbers do we have when we're dealing with age? How many 1-year-olds do we have? 0. How many 2-year-olds?
1.
So we have 1 2-year-old. How many 3-year-olds?
3.
So we have 3 3-year-olds. So we put 3 3 times. How many 4-year-olds?
1. No.
No 5s. 1 6. No 7s. How many 8s? We have 8 appear twice. We have 1 9 and 1 10. Okay. You got it there. Hey, try to be like be mature. If you're not, you should act. Then you could grade drama in high school and stuff. You'd be good. All right? Good acting. Okay. All right. 2, 10, 3, 9, 3, 8. All right. I have 2 middle numbers.
Don't you like add them and then divide by 2?
Man, Kelly was even raising her hand, and you threw your voice right to
Well
her.
done.
Well done. Kelly, what should we do?
You add the 2 and divide by 2.
Add the 2 or divide by 2. Now, if it has a perfect number right in the middle, like when I add 4 and 6, I get 10, and divide by 2, I get 5. I take the average of those two. So we take the mean or the average of those two. Okay. Here we go. Notice 5 comes in between 4 and 6. So if you got 8 as your answer, that would be bad since 8 isn't even in between 4 and 6. The number you get should be between those two. All right. Here we go. All right. What's the mean? What's mean mean? Means average. Yeah. The average. Okay. So the average, we have to add all numbers.
And divide by.
And divide by the number there are. All right. So in this case, we have to add them all up. So we have them all here. 2 plus 3 is 5 plus 3 plus 3. Well, that's 9, 10, 11. That's 10 more. 21 and 16. What'd you guys get? Anyone get the mean? What'd you get, KK? 5.6. 5.6? Is that what everyone got? Yeah, what'd you get? 5.2.
I got 5.6.
5.6. Okay, they all add up to, do they add up to 56? Yeah. Add up to 56. So the sum of them, when we add them up, is 56. We divide by 10. Okay? So in this case, 56 divided by 10 is 5.6. Okay? All right, what's the mode? What's mode mean? It's weird we say that. Go ahead, Brina.
The number that shows up the most in the
Good. The number that appears the most. All right, so now we've defined mean, median, and mode. Give you another name for those here in a minute. The one that appears the most is?
3.
Yes, Peter.
3.
It is 3. Okay, 3 appears the most. Now what happens if you have multiple numbers that appear the most?
Don't you like add them and
Yeah, you write both of them. What if everything only appears once? Are they all modes? No, there's no mode then. Okay? Now, when we talk about mean, median, and mode, there's another name for it. Anyone know that name? They're called the measures of central tendency. Measures of central tendency. Okay?
oh, you write that down.
Yeah, write that down. You should have hopefully these definitions down if you didn't know them. And then measures of central tendency. I'll try to zoom in there. I'm going to answer question F first. Does the line plot give you all the data available? What does that mean? Does it give you all the data available? It tells us the age, tells us the number of dogs. I guess it doesn't give color or anything like that, but yeah, it gives us all data available, for sure. Okay. Any questions there?
Why is it that you
Okay, the bottom you can do later, but I want you to take a look at number 2. So during class, if you finish up and you're waiting for the class to move on, go back and do the rest of problem 2. Okay? That'll be part of your assignment today. right? Now this whole packet won't be our assignment today. We'll get to what we get to. And at the end of class, we have to take the district part of the test from yesterday, which is about 5 problems. You'll be okay. You'll love everything. I forgot about it.
Why did you split the test up? I was all in test zone yesterday.
Yeah, you're in test zone today, too.
No.
Here, I'm preparing you right now. Okay. Number 2, circle graph. Now, if you remember, like in our front part here, we had circle graph. Circle graph, everything adds up to 100. It's a full 100%. Okay, all your percentages, all the pieces have to add up to 100. Okay, and the different parts of the circle graph, also known sometimes as a pie graph, but those different parts, if the bigger the percentage, the bigger the portion. They're supposed to be proportional if the circle graph's done correctly. Okay, so I want you to work with your groupies on part 1 here. Best you can.
Well, 20,000 is 100. 2,000 is 100.
Okay, can I have your attention back up here? The circle graph shows the Corbett family's monthly budget. So your attention means you're not talking, I am though. Okay? The Corbett family's monthly budget or monthly income is $2,000. How much cash is being spent on housing? Well, we have the circle. The circle represents what percent? Person 15. Who's that? Kelly. Go ahead, Kelly.
You didn't even hear
The circle represents what percent?
100.
Yep, circle represents 100%. And in terms of 100%, how much cash is that if we're dealing with the Corbett family's monthly budget and their income? Okay, this should say, I mean, this is their budget and their income is total. Oops. Go ahead, Kylie.
$2,000.
$2,000. Good. So this represents $2,000. This whole piece here. All right. So in that case, how much cash is being spent on housing? Here, hold on. Let me get someone there. Person 12. Who's that? Haley.
Oh, hey, $800.
$800. How'd you get that?
I just took 2,000 divided by 100 and then times by 8.
So you took 2,000.
Yeah,
You divided by what?
100.
100?
Yeah.
And then did what?
Then
Why did you divide by 100?
Because it's out of 100%.
Okay. I was just wondering. And then what'd you do?
And then I multiply my result by 40.
Then you multiplied by 40? Because there's 40%?
Yeah.
Okay. Good. All right.
Oh, it's classic.
All right. So you got 800. Okay. Well, hold on. Let me get
No, yeah,
person 6. Dylan. Actually, any other comments on that? Brina, what do you got?
I did 2,000 times 0.4.
So you did 2,000 times 0.4? Did that give you 800? Okay. Hey, Brina's going to explain why she did 2,000. By the way, Haley, that works. Good job. Okay. Brina, you're going to explain to us why you did 2,000 times 0.4.
Because if you convert 40% into like a decimal, or you get 0.4, and then when you multiply that by 2,000, then you get 800.
Okay, so all the cash is 2,000. So if you take 2,000, multiply it by 0.4, which is 40%, that gives you your 800. Good. This, yeah? What'd you do?
Well, what I did was I got 2,000, and I got 40%, so then I divided 1,000, so basically it's 1,000, so then 40% of 1,000 is 400, so I just added 2, so I got 800.
So you did it like in your head? Well done, man. Okay. Good, those all work. Hey, how much cash is being spent on food? Person 13. KK.
Ooh, $600.
$600. Anyone second that? Okay. How do we get 600, KK?
We multiplied 2,000 by 60. Wait, not by 60. What am I talking about? By 30%.
By 30%, which is what decimal? 0.3. Okay. All right, well done. What should all the percents of the graph add up to? Marley? 100%. Well done. Why, Marley?
You can do it, Marley.
Think of that circle. Think of that circle as, it's kind of a hard question, but think of that circle as like a pizza, right? This represents your entire realm of your budget. You can't add anything else, otherwise it doesn't fit together perfectly. So it represents your entire part. Okay? So since the whole circle's filled up, that's 100%. If you took a slice out, then you no longer have that 100%. Okay. Hey, let me making sure that we understand the entire budget adds up to 100%. Okay? That's why the circle graph, or it should add up to 100% because that represents their entire budget. All right. You have part 2 and part 3 on the bottom, but we're going to move on right now and go back to that at a time later. Okay? I want you to take a look at data tables, part 3. Part 3, data tables. I want you to do that first part 1 under data tables, so A through D. Here, please.
No, yeah, because that's what I thought it was.
Everyone's eyes and ears focused here. Hey, guys, before, I know you've done data tables, and I want to talk about that here in a minute, but then we're going to go back to the circle graphs one because I forgot there was a second piece we needed to talk about. But let's go ahead and finish data tables here. The mean number of books. Mean means average. So the mean, person number 8, that's Kylie.
Kylie, woo! Let's go. A.
Yeah.
235.5.
235.5. Yes, that's correct. So we add up all of these, the number of books. We find the sum and divide by 4. What was the sum? What's your question, Kelly?
Do you round?
We're not going to round right here. We're going to leave it. Yeah. If you rounded to 236, it'd probably be okay, but I'd rather you leave it in decimal form. I know we're not going to tear a book in half and take half the book. That'd be kind of bad. But, Rena? 942. So the sum is 942, and we're dividing it by 4. Well done. Okay? What is the median number of books? Yes, Emily? 234 and a half. Remember, median is when we put all the books in order from least to greatest. So 232, 232, 237, and 241. And then halfway in between, we've got to add those two up and divide by 2. That gives us our 234 and a half. Oops, this should be down here. Sorry. Yeah. Okay, we went through that. You just weren't weren't listening. Sorry, man. You have to talk to your neighbors now. Okay, letter C. What's the range in the number of books based upon book kind? Okay, person 15.
Boom.
9.
Boom. All right. Hey, the range is 9. Okay, 9 books. Now, the way we got that, it's a different type of range than we did before. The range before we said it was 232 to 241, right? That was the range. Now, a lot of times to find that range, this is the numerical range. From here, there's 232 to 241. But if we subtract those two numbers, it actually gives us a range of 9 books. Okay? Good job. All right. What is the mode? Person 3.
$232.
232. Well done. Yeah, the one that occurs the most often there is 232. Okay. Any questions there? All right, I want to go back to the previous page. Amanda pointed out a good question there. So Amanda got a point for that. Good job, Amanda. It was a great question. Okay. So Marty surveyed 24 students and asked them to name their favorite fruit. The circle graph on the right that shows the results of the survey. And then it goes through which fruit was the favorite of exactly 12 students, how many students picked apples as their favorite, and if 4 students chose banana, what is the angle created by the circle graph for bananas, how many degrees, and if the angle of the orange is 30, how many students picked oranges? Okay, well, first this one doesn't have any percentages on it. But it does tell us that there are 24 students. And 24 students represents what percent, Dylan? No, Emily? 100%. Okay, 24 students represents 100%. Okay? Yeah.
Can I answer one?
Well, can you tell me exactly? Yeah, go ahead. What's it? Let's letter D.
It's grapes.
It's grapes. Yeah. How come?
Because grapes is half the graph. So 24 minus, or divided by 2. I can't even get it out.
Yeah. So this is exactly half the graph. We can see that. So that represents 50%. 50% of 24 is grapes. Okay. Go ahead and tell your neighbor how many picked apples.
6.
Okay. Person number 10. He's not here, Taylor. Unbelievable. 16. Elliot.
10, or not 10, sorry.
You spit it out so confidently.
said it.
I was wrong.
Go ahead, Elliot.
6,
6. Good. Okay. So what percent is that, Elliot?
12%.
No, of the graph.
Um,
Apples represents what percent?
He's got it. He's got it.
25%. Good job. So, and that represents 6, right? 25% of 24 is 6. Good job. Unbelievable. Ethan? Who used my calculator out there? That's just like leaving $120 laying on the table. I know we're all trusting and stuff, but good night, man.
Good night.
Jeez. All right.
That just made me
If 4 students chose bananas, what is the angle created by the circle graph? I want you... Wow, you have a few people that have it. Okay, we'll just go in that group. They all had their hand up. Go ahead, Kelly. Or
60%.
now, how'd you get that?
Or 60 degrees, sorry.
How'd you get that?
Because bananas and oranges, that's like 90%. Or 90 degrees.
Okay.
And then on G, it says that oranges is 30 degrees. So then I did 90 minus 30, which is...
Wow, everyone see that? 90 degrees. Oranges is 30 degrees. So, if that part's 30 degrees and this whole thing's 90 degrees, then that makes this 60 degrees. Okay, so 30 degrees. Well done. Okay? Everyone get that? So, once again, this is 1/4, right? So it's 90 degrees. It's a 90-degree angle. And oranges represents 30 degrees. They tell us that down here. So 90 degrees here minus that 30 gives us 60 left over for bananas. If the angle of oranges category is 30 degrees, then how many students picked oranges? Amanda, what do you got?
2.
What's that?
2.
2? How'd you get that?
Well, I did 30 degrees divided by 350 equals 3.6.
Okay, let me pause right there. Everyone see what she did there?
Yeah.
30 degrees divided by 360.
Alright,
Okay, that's 3.6.
No.
Oh,
Then I divided that by 3.6, which was 8 1/3 over 100, and I multiplied that by 0.25 and got 2 over 24.
holy moly.
Okay. I have
So could that's a way we could do it. Okay, Kelly, what do you got?
So for F, it said for 60 degrees, it was 4 students, so half of that. Oh wait. Yeah, it would be.
Okay, let me pause. Ethan and Skylar, you guys go outside, please. Okay. Yeah, 60 degrees is 4 students. Very true. So that means this would be half of that, or 2 students. Okay, that's one way to go. Go ahead.
Okay, well, we know that the apples was 6 students, so that's 25%. So the other half of that side is the other 25%, so that's 6. And then we know that the bananas is 4, so the oranges has to be 2.
Okay. So you're using elimination there, right? You're saying that this is 12. This represents 6. This part represents 4. So we have 6 plus 12 is 18 plus 4 more is 22. So this has to be, if there's only 24 students, This has to be 2. So, Amanda, mathematically what you're doing was right, but like you're asking me, we made it a little harder than we probably needed to. But that's good math you're showing. So, all right. Very good. Any questions there? Pretty good stuff. All right, let's move on. I want you to move to stem and leaf plots, number 4. Hey, this is the last one we're doing today. Stem and leaf, number 4. Hey, if I could get your attention back up here real quick, let me give you a hint on how to read these. Okay, stem and leaf plot at the right shows the ages of the people who attended Mayor Burns' recent speech. And notice over here on the front page, stem and leaf plot shows all the data. 5, line 6 represents 56. So like right here, 5, 6 represents 56. So that means these stems, these are just stems. They're telling you what number you're at, or what part of 10 you're at. So like 30s, 40s, 50s, 60s, 33, 38, 38, 38. Okay, so if I want to figure out how much data is in this graph right here, or in this table, each one of these leaves represents a piece of data. So there's 4 here, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 pieces of data in that one. If I'm looking at this one, everyone figure out how many pieces of data are in our mayor speech one. How many pieces, Amanda? There are 10. Good. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? There you go now. The stems don't count as a piece of data. They're just saying how or what part of 10 we're on. 10, 20, 30, 40, 50, 60, 70, 80. Dude, there's an 81-year-old person there. Holy moly.
That's what I said.
It's awesome. Okay, here we go. Close race so far. Person number 13. How many people attended the speech?
What did we just see?
Person 13. That is KK.
Woo, what would you say to that?
Yeah, how many?
10 people.
10. Good. We'll give you the letter B then. All right.
Okay.
Go ahead, KK.
The youngest age is 18 years old.
Good. The youngest is 18. Well done. All right. Person number 7. What's the age of the oldest person? It's Charles. He's not here. Person number 4. Austin. 81. Holy moly, man. All right. What was the range of ages? Person number 29, or we don't have in here. Person number 7. He's not here. Person number 5. The range? All right. How about person 12?
Kylie?
Haley.
Oh, okay.
It ranges from
18 to 81. Well done. Yeah, youngest to oldest. Good job, Haley. All right, what's the median age? Right here. Yeah. Yeah.
Yeah. Okay, 34.
34. Not quite, I don't think. I think we're missing that. Close. Dylan, what'd you get? He was the second one. 42 wasn't correct either. Go ahead, Emily. 38.
No.
Yeah, so let's figure that out real quick. We have 18. We have 21. We have 17, or 27. 30. 38. 38 3 times. Holy cow. Okay, and then 45, 46, and 81. Okay, let's get all those on there. Okay, so we have all those, that. Notice I just crossed one out. And boom, 38. Okay. You guys figure out what happened? Okay. What's the average age? Person 12. 38.2. Well done, Haley. Okay. We add them all up. What was the sum? Person 19. What did we get there? Dan, that's you. Oh. Person number 7. He's not here. Person 17. Anya. Okay, volunteer. Yeah.
Yeah, Kylie.
What is it? No, the sum. Add them all up. Amanda, what'd you get? Go ahead. Yep. Huh? 382. You guys, even if you didn't have the sum, how many people are there? 10. You just multiply it by 10. 382. Oh, divided by 10. Yes, I know. We could have just moved the decimal. The whole last chapter. All right. What's the mode? That says divided by 10, guys. Oh, I got to draw a number here. Person 8. Who's 8?
Kylie, you're 8.
Kylie. You're 8. What's the mode?
I had 38.
38. Well done. Yeah, it's the one that occurs the most often. 38 does. Was there an outlier? Hey, there's a new term. Outlier means it's away from all the other data. Okay, Elliot?
Yes.
Which one? 81. Now, there's actual formula. Okay? Explain 81 is away from the cluster of data. Here's the cluster. 81's farther from that cluster. Now, there's an actual formula for that. We're not going to worry about that. Right now, we're not anyway. Right now, we're just looking at the data. Okay, your assignment tonight is to finish through this page. So you start at the front, and you finish up to this page. Okay? And then tomorrow we'll pick up from there.